Okay, let's talk about langchain-rust library. So craze.io, um, langchain-rust. So the features are we have support for most of the famous LLMs, OpenAI, Azure, OpenAI, Olama, and Anthropic Cloud. Embedding support, we have OpenAI, Azure OpenAI, Olama, and local fast embed. Vector stores, OpenSearch, Postgres, Quadrant, SQLite, and SurrealDB. And chain, LLM chain, uh, yeah, let's see. I'm not sure. We can go through this. Agents, chat agent with tools. Tools, I think some of them not implemented. SERP API Google. I love seeing this coming up in Rust, LangChain Rust. Yeah, having said that, let's go through an example. So this is a small program I have created. We have langchain rust uh, dependency and feature with Olama and Saturday JSON, and we need Tokyo as well for the runtime. So let's go to the main.rs. I'm downloading, I'm importing language models LLM and LLM Olama client, and we need the Tokyo main runtime because the API calls are async. So we are building an async function main, and Olama default with Tiny Olama. I have installed Tiny Llama, so I'm using this model for running this program, and I'm invoking Olama model with what is the Amazon stock price today. So there is no rack. Rack is the, let's see what is rack. Do they have any explanation here? Rack. No. Um, what is rack? Well, let's see in AWS documentation. Retrieval augmented generation. So basically it should retrieve latest price, but um, I haven't integrated with Google. We don't have LangChain Rust with SERP API. So let's see what it is bringing. Um, I can simply build this with cargo build. Before that, you need to install Tiny Llama. So for that, I think I have downloaded that sometime back. Tiny Llama download. I think from the Llama site itself. Yeah, you can download from here. I downloaded for Windows and installed it. Okay, so coming back to this, building this, it's already built, so that's the reason it's finished fast. Otherwise, it might take some time. And just run cargo run. It's running. It's getting running through the model, calling the APIs, and it's taking time. In between, let's quickly touch base with what is LangChain, at least. quick start, langchain. Quick start to best understand the agent framework. Let's build an agent. Two tools, one to look things up online and one to look specific data that we loaded into a index. So langchain. Yeah, these are the three things actual langchain support brings up. Um, yeah, langchain has chain agents, retrieval strategies. So yeah, what is RAG? RAG is augmenting LLM knowledge with additional data. So let me run. Yeah, current Amazon, this is what retrieved. Current Amazon price, this writing display 2021. So that means it's not retrieving the latest price. It's just getting the old one. So there is no augmenting. It's just looking for the previous LLM trained data. So that's where the RAG is coming. We can use SERP API to Google search. That is not implemented in langchain-rust. So that's not our aim, but I just want to show you this is what basically um, it's doing. So what we are trying to cover in this uh, video is just to see how LangChain Rust code is implemented, what kind of uh, source libraries, um, what is the module structure, and what are the features they implemented, how the code is structured. That's what we are going to see, and some of the examples we can try to see how to call, use LangChain Rust. Having said that, let's go to the SRC itself and everything in a module um, library. It starts with the lib.rs. So we have so many modules: agent, chain, document loaders, embedding, language models, LLMs, prompt, schemas, tools, vector store. There are separate all the features they created separate modules. That's a good thing. And let's see an example. LLM Olama itself. So they are importing LLM Olama, the same as what I did, and the feature used Olama and Tokyo main. So the runtime they are using Tokyo main and async main, the same thing default. I used Llama. They are using Llama 3 and they are Olama dot invoke and using an invoke prompt and waiting for the response and displaying that. This is async way, and this is the oh, not alarm. Okay, alarm feature is not enabled. Then yeah, run through this. Yeah, so basically this is the way we need to run. So let's go back to uh, LangChain itself. Architecture. I don't want to read through all this. Uh, what I want the features. components. Yeah, components. So we have LLMs. What is LLM? LLM, large language model, are a core component on of LangChain. So how to write a custom class? So this is basically written everything in Python. So all the examples are in Python. Let's see how, yeah, this, if you look at here, they're streaming property prompt custom LLM. Oh, it's a custom LLM. Um, I don't want to go with custom LLM. Let's see some, yeah, LangChain, OpenAI, import app OpenAI, and they're using OpenAI key and just calling and invoking it. So same as what we have done here in our example, invoking it. So let's see where this invoke is going. So invoke is going to llm.rs. So let's see, we can split the screen. Can I split the screen? Uh, Split editor. Okay, leave it. I don't want to split the screen then. Uh, yeah, it's here, llm.rs, and we will go back to the source code. I want to close all this rack. I'm closing. Yeah, llm.rs. Where is that? So it should be in LLMs. Let's see mode LLM invoke, right? llm.rs. Here in LLM Olama client. Where is the invoke function llm.rs? Let's go back to this. It's under SRC language models. Language models. SRC language models. Okay, llm.rs. And all, yeah, it's a trait. Yeah, async trait is for building async functions inside a trait. So I think this feature is there in latest Rust, but I'm not sure. But they are using a separate library for it. That's what async trait. Here we have this invoke trait function. So trait is LLM. All the uh, all the objects implementing LLM trait can use this invoke. So invoke is basically self.generate. So now we can go back to here, self.generate. What is generate? What is generate? Oh, here itself. Generate is another async function which accept messages and return a general result with LLM error. Okay, yeah, and so let's see what Olama has, how Olama has implemented this Olama, Olama client models and options. That's what this struct is. It has a client, Olama client and model, so string options, generation options. Okay, with models, generate request. Yeah, here it's return a chat message request. Default for Olama, new client. Yeah, implement LLM for Olama. So we here they are generate, yeah, defining, implementing that generate async function. So it is self dot generate request message iter chat and return a chat message request. Implement, let's go back here, Olama, and implement LLM for Olama, generate request. Okay, and generate request messages, and it will return a chat message request. And chat message request can be passed to send chat messages to the client, and it will respond a chat message response. And that message response we can result.message match, and if message is there we can message to message.content. Okay, that's what LLM Olama generate is doing. And tokens, yeah, this is another token usage, tokens, and basically it is generating a generate result token slash generation. Okay, with content and tokens, that's what it's returning back. Okay, fine, fine. So, yeah, invoke. What invoke is doing? Invoke will return LLM error, and if it's no error, generate map. Okay, generate result. Basically, it's returning a generate result, and it will stream. Oh, that's a separate function. So that was doing. Yes, basically it's getting a generate result. So how does generate result? Generate result can be hash map, map insert. Okay, it's a map. Agree tokens plus generate, where it is calling the all llama API. That's what I want to know. LLM all llama default with model client invoke. It should be an invoke. It should be an invoke. Generate. Okay, and we'll see language model generate result, token usage. This is what we are importing in this client.rs. Where is this client.olama.client.rs? Okay, it's specific to Olama. Good. Olama as Olama client, Olama client. Okay, what is Olama client? Yeah, we have a request client here. Olama, where is this? Where is it? It's a struct Olama. Yeah, struct Olama me. Okay, it's a URL request client. Okay, base request means it's going to call the request, give a request on this URL most probably. Let's see where it is. URL, URLs. Oh no, I don't want to go that deep. This URL. Where are we setting this URL? Oh, okay, here. Default is this one. Okay, yeah, this is where I installed the uh, tiny llama. Okay, basically it's calling here and creating a request and basically returning it. Okay, that makes sense. That makes sense. Yeah, that's how it is working. Basically, the simple example, that's how the flow is. Olama here, we can see client.rs Olama is this. And if I go back to this, it's not an Olama client. That's what it's strange. How come this struct is not an Olama client, but it's pointing here? How come? How come? Uh, 17 implementations. Not this one, not this one. No, not this one. How Okay, let me go to this code. Olama client.rs. So I want to see where is the Olama client. So Olama client is here, where it is importing from. It's importing from the crate. So Olama client, where it will be then? Node.rs? No. Language models? No. It's a crate. Okay. Minimize tools, LLMs, language models, chain agent. Should be here itself, but it's not here. Client. We can define anything, but this should be the Olama as Olama client. Oh, okay. They are importing Olama RS. Use Olama RS. Oh, Olama RS. Is it? Is it another library? Um, I'm checking all the dependencies. It's not a library. Olama RS. Do we have Olama RS here? Source LLM. We don't have Olama.rs language models. Options LLMs. Oh, use means it should be examples. Building Olama RS. So it should be a dependency. Insert Tokyo. AWS config. Yeah, Olam RS. Olam RS is a separate library. What is that? Create.io. Let bring. Oh, it's going somewhere else. Create Rust. Yeah, let's see what is olama.rs dash rs. Yeah, this one is 2 months, pretty new library and simple and easy to use library for interacting with Olama API. Okay, yeah, you just need to give the URL and port, yeah, and prompt and generate. Okay, yeah, generation request is coming from Olama itself. Okay, going back to this library. So this is, yeah, this is an Olama left, right? Okay, RS, yeah, true. So this one, Olama client, to build Olama, generate request. Oh, Olama.rs, they are getting chat message. Oh, chat message is from this library itself, not something langchain.rs build. Okay, so they are mainly relying on this Olama underscore rs library. Great. Okay, generation, chat, request, okay, message on, options, generation options. Okay, I think we should look at this as well. Completion generation. So generation option are default. Yeah, these settings are in this generation options. Okay, and show model info. Create a model. Embeddings. So we can do prompt like this and generate embeddings like this. So yeah, uh, let's see an example how LangChain is connecting with Olama.rs for embedding. What I want to do is this LangChain embeddings. Embeddings is segmenting the text in order to get more context on the input what we are giving. So okay, let me go to that code. Olama embeddings, embedders, and embedded is again calling all need Olama client. Basically everything is internally connecting to this Olama client, and which is basically coming from Olama underscore rs. And how it is calling the things. Impel embedder for Olama embedder, and capacity generate embeddings. So generate embeddings is basically a Olama rs feature. So functions. So we are using that to get the embeddings from Olama. Okay, that makes sense. And what is embeddings? I just want to touch base that also. Let's see what is the definition in lang chain. Do we have lang chain documentation opened? Yeah, here. Embeddings, components, embedding models. The embedding class is a class designed for interacting with text embedding models. There are a lot of embedding models providers, OpenAI, Cohere, Hugging Face, etc. This class is designed to provide a standard interface for all of them. In LangChain, basically they are using Python to connect, but query, but we are directly calling Olama. So let's see how Olama embedding. Yeah, this is the official site for olama.com. Embedding models. Yeah, they are vector embeddings. This text they are converting to a vector, and that will be used for getting the output. So generate embeddings. So we can give it documents like this, and olama.embedding will give embeddings response. Lastly, use the prompt and document retrieved in the previous step to generate the answer. So with this embeddings, we can generate answers. Once we have created the embeddings, we can use that when we are giving a prompt. Generate a response combining the prompt and data retrieved in step 2. Okay. Yeah. Version 1 dot embeddings API compatibility is what they are using. This is OpenAI. Okay. Coming back to here, embedders. Internally, it is calling Olama RS. So basically, it is calling, relying on Olama RS for everything, and for asynchronous functionality, it is using async trait. Okay, I think that's all I need to cover in this video. We will go through either this or some other crate in the coming videos. Thank you so much for watching this video. Thank you.